Okay, so we're told the triangle ABC is such that AB is 11 centimeters, angle BAC is 110 degrees, and we're told, given the area triangle ABC is 31 centimeters squared, find the length of BC. Any question where you're not given a diagram, this is a geometrical problem. We should be representing it visually with a sketch. My sketches are awful. A sketch is just a sketch, just something that visually represents what's going on to organise our information, because your brain can't simply process and store the information in a way that's really, really useful to solve this problem. So AB, I now know that that side AB is 11 centimetres. I'm also going to load that little side C, load that little A, that little B. Okay, I'm also told the angle BAC, so that means that this angle here is 110 degrees. Area is 31 centimeters squared. We want to find the length of angle BC. Okay, so we're looking to find the length of BC. So we're looking to find this side BC here. Now, when I look at this, the information I'm given means that I can use the area of a triangle to find this missing side B. Okay, I know that's not the side we want the side BC, or this one over here, but once I've found the missing side B, I can actually then use the cosine rule to find this missing side A over here. At the moment I can't find it directly with the cosine rule because I'm missing two sides. Okay, so let's start off with the area of a triangle. So the area equals half. In this formula we're looking at a half BC sine A. So the equation I set up is 31 is equal to half times 11 times, let's just call it X at the moment, actually let's just call it B at the moment, times B times sine of 110. Okay, so if I now divide both sides, half times 11 is 5.5, so I've got 5.5 sine 110. If I divide both sides by 5.5 sine 110, what I get left with is that B is equal to 31 over 5.5 sine 110 degrees. So this gives us the most accurate answer possible. Just working that out on my calculator now. It's important that we get the most accurate answer possible. As you'll see when I work through this question now, what I get is an answer of 5, or actually it's 5, it rounds to two decimal places, it's 6.00 centimeters to two decimal places. Okay, that accuracy is important because later on, hopefully, it's going to make perhaps some of our other working a little bit more simple. Okay, so at this point, I can now use the cosine rule. The version of the cosine rule I'm going to be using is where we've got cosine of A. So this is going to be A squared equals B squared plus C squared minus 2BC cos of A. So I don't know what A is, so I've got A squared is equal to 11 squared plus 6 squared minus 2 lots of 11 times 6, and then cosine the angle that we know, 110. So when I work this through, I'm just going to take the square root of both sides. I'm not really going to work much out here because I just want an exact answer. So I mean, there's nothing wrong with just doing this and not working anything out. I mean, obviously there's bits of arithmetic you can do, but I'm just going to leave it like this for the time being. 11 squared plus 6 squared minus 22 times 6, 132 cos 110. Okay, so when I work through that, obviously we want to take the positive result for that, and you will get an answer of 14.22 centimeters, again to 2 decimal places. Okay, so let's have a look at what we get the marks for here. First method mark is for using the sine rule here and setting up the equation to solve. You then get an accuracy mark here for finding that B is 6.00 centimeters to 2 decimal places. We can have a method mark here for setting up the correct equation using the cosine rule, and then we get an accuracy mark at the end here for getting that the answer for BC is a 14.22 centimeters to 2 decimal places. Okay, I hope that made sense. So let's have a look at part B. Part B says the triangle XYZ is such that XY is 2 centimeters, YZ is 2 root 3 minus 1 centimeters, and XYZ is 60 degrees. We want to find an expression for XYZ in the form of this surd, where M and N are integers whose values are to be found. Okay, again, let's draw a triangle for this example. So X, Y, and Z. I'll just put in a little x, a little y, and a little z. Okay, so we know that xy is 2 centimeters. So actually I can put this as 2 centimeters. We know that yz is 2 root 3 minus 1 centimeters, and yxz, so this angle here, is 60 degrees. Okay, so we want to find an expression for the other angle, which is this angle here, xzy. So we want to find it in this form of the surd here, which is rationalized. What we can do here is, this is a sine rule because I've got a complete angle side pairing. So I'm going to be using, because I'm finding an angle, I'm going to put the angles on top. I'm going to have sine x over x, and all I'm doing is using the sine rule but replacing like a and b with variables x and y and z. That's going to be equal to sine z over z. So when we substitute in our values, sine of x will be sine of 60 over x, which we know to be 2 root 3 minus 1. We're then going to have equal to side of z, which is, sorry, sine of z over the side z, which is 2. Okay, I'm going to multiply both sides by 2. This will get rid of this denominator here. So, and I'm actually going to split the sides so we get sine z equals, at this point, sine z equals sine of 60. Okay, exact trig angles here. If you can't remember them, draw it out. So that's 60, this is 30, this is 1, this is 2, this is root 3. Sine of 60, opposite over hypotenuse, is root 3 over 2. So what we're going to get is root 3 over 2 times by 1 over root 3 minus 1. Okay, so tidying that up, sine z will be equal to root 3 over 2 root 3 minus 1. So to get into my rationalized form, I'm going to have to multiply by the conjugate of our expression down the bottom. So this is going to be 2 root 3 plus 1 over 2 root 3 plus 1. So when this works through, we're going to get sine of z equals let's do the top first. Root 3 times root 3 is 3, times 2 is 6. Root 3 times 1 is plus root 3. For the denominator, I get 2 times 2, which is 4, times 3 times 3, which is 12. I then get minus 1 times plus 1 is minus 1. So when we tidy this up, sine z equals 6 plus root 3 over 11. Okay, so let's have a look to see how we get the marks here. Okay, so initially we get our first method mark for using the sine rule correctly. So again, as I always say, making sure that you've shown the substitution into that sine rule. You then get a method mark for getting to this stage here, where sine z is equal to a rearrangement we need to evaluate, and then finally we're going to get an accuracy mark for getting and showing how to get down to this final expression here. Okay, I hope that all made sense and that you understood it.